Imagine you are analyzing huge data set of number and someone asks you a simple question. What is the maximum average of any subarray with given k size? Sounds easy, right? But here's the catch. The array might contain tens of thousands of elements. If you calculate the sum of every possible subarray from the scratch, you are going to repeat the same work again and again. And that's exactly where most of the brute force approach fails in coding interviews. But there is a beautiful pattern of algorithm that solves it elegantly. It is called the sliding window protocol or sliding window technique. Instead of recalculating everything, we are simply reuse the work we have already done and we update the result as our window move across the array or the given set of elements. Think of it like fixed size window of the train. As the train moves forward, you do not restart the entire window or entire view. You simply remove what left from the window and add what entered. And with this one idea, we can reduce the complexity of problem from n square to big O of n. In this video, we are going to understand this pattern using one of the most famous problem in Leetcode, Maximum Average Subarray Part 1. By the end of video, we will notice that why the brute force solution fails and waste our time. You will also get to know the core intuition behind the sliding window pattern and how to write a clean Java implementation that interviewers love. Once you understand the problem and how to use this pattern, you will start recognizing it in dozens of other coding interview problems. So let's start by understanding this problem first. See this problem, we have given number of integers and we have given the size of window. We simply have to return the maximum average possible within this window. Let's see this brute force approach, what we can do here. So for a given array, we can find all the possible array of size k and their sum, and we can print or store the average of each, and at the end we can return. This might give you the time complexity of n into k. Now let's see this in action, how this works. So now let's see this problem in IntelliJ and let's solve this one. So first we can just store the length of this array into n. We can initiate the max average variable with the negative infinity so that anything positive to that will give you a positive result. Now we can start this for loop and start visiting each number one by one. Also we can have a sum variable, but you observe this for loop, right? We are not going to cross n minus k. So n is the length of that array and k is the size of window that is given. So we'll just go up to that point where the size of k length array is possible, and for each possible sub array of length k we can introduce another for loop to find the sum, like this one. So we will start from where I start and we will go up till the kth size. Like for this example we have k size as 4, so we go up to 4 and we calculate the sum. Once we have sum, we can simply calculate average and we can store max average in the variable we have already introduced, and at the end our job is just to return that max average. Now let's see if we are good with this or not. So yeah, it is returning 12.75, and if you see the Leetcode, we have taken just this example and we are getting exactly what we wanted. Now try to think about optimizing the solution. As here we are introducing a new pattern called sliding window. So we will leverage that sliding window pattern and try to find out how we can work with that. As we have already given the size of array, I mean the window size, and that is fixed, so we can just move that window and try calculating the maximum average. Let's see that in action. So before that we start, I just want to inform you that we have two kind of window, a variable window and a fixed window. So for this one we have fixed window, but going forward we'll also try to see problems related to variable window. And anyhow you have to learn this pattern because this will solve you most of the problems for Leetcode and you will feel outstanding respective to other candidates. Now let's introduce the window sum as 0 that we will return at the end. Window sum will use in between. So let's first just try to calculate the sum of element of the window size. This will give a start, and that's a simple for loop we can use. We can introduce this max sum variable and initialize with this window sum. So at the beginning the max sum is equal to the sum of the current window. So going forward we'll keep on adding the next element and subtracting the element which are leaving the window. In this way we will able to get the sum of each window every time and apply other logic. Now parallelly let's do that with using this for loop. We can start from k and we will go up till the end of that array, and as I mentioned, window sum for an instance will always be the sum of next element, and we have to remove the previous element or the first element which are leaving the window. So that can be achieved by this line, and this line is very important in terms of both static size of window and variable size of window. Now we can calculate the max sum by simple math formula, or the max formula, in which we can see for every time if the max sum is the maximum or the current window sum is the maximum, and we'll store that in max sum, and at the end we'll simply return this average, because if we found the max sum, the average is also the maximum. Now let's try to run this in Leetcode. Now we are here in Leetcode running the sample test cases, which is passed, and now let's submit this. So we have beaten 99% of the programmers out there. Let me reload this so you'll see how we are able to beat 99% of the programmer. But the idea is simple. You have to understand the functionality behind the sliding window, in this case the constant sliding window. So we'll see you the next one with some different technique.